Normal probabilities. The normal distribution has these properties. It has a mean mu, which defines its center. This is also where the tallest part of the peak in the graph will be located. It has a standard deviation sigma, which defines its width. It is symmetric, mirror image, about its mean mu. It is bell-shaped. The total area under the curve is 1. The area to the left of mu is 1/2 and equals the area to the right of mu, which is also 1/2. The standard normal distribution has a mean mu equal to 0 and standard deviation sigma equal to 1. Any normal random variable x can be transformed into a standard normal random variable z by the calculation z equals x minus mu divided by sigma. Suppose IQ scores follow a normal distribution. That is what the tilde or squiggle means, where the mean is mu equal to 100 and the standard deviation is sigma equal to 10. Notice there's the general notation in the top line of the horizontal scale, the IQ values in the middle, and the standard normal or the z-score scale at the bottom. In the very center, where the blue graph is tallest, we have the mean mu, the IQ score mean value of 100, or the middle of the z-score scale at 0. The first value to the left of the middle is mu minus 1 sigma, or 100 minus 10 in the IQ scale data, which is 90, or negative 1 on the z-scale. The second value labeled to the left of the center is mu minus 2 sigma, or 100 minus 2 times 10, which is 80 on the IQ scale, or negative 2.00 on the z-scale. The first value to the right of the middle is mu plus 1 sigma, or 100 plus 1 times 10, which is 110 on the IQ scale, or 1.00 on the z-scale. The second value to the right of the center is mu plus 2 sigma, or 100 plus 2 times 10, which is 120 on the IQ scale, or 2.00 on the z-scale. You will need to be able to sketch this type of graph to gain a good understanding of how to find answers related to the topic of normal probabilities. Typically, we start with a random variable of interest, x, which has a normal distribution with parameters mu and sigma. X will be the value of some measured characteristic of interest. We transform the question asked into one involving the standard normal distribution, or z-scores. This is the power of the normal distribution, which only requires one table to do all exercises. Begin by transforming from the given population into the standard normal curve values by creating z-scores. Recall that a z-score is simply how many standard deviations above or below the mean a raw score is located. The standard normal probabilities table, or table Z, gives the proportion of all z-scores which are less than the z value you locate in the table. You will learn to use this table to find the proportion of z-scores under any part of the normal distribution curve. This proportion is represented by the area under the curve. First example, what proportion of all z-scores are less than 2.15? In other words, how much of the total area under the z-curve lies below a z-value of 2.15? Be aware of the difference between the z-score values on the horizontal axis and the area you're finding under the curve. Before answering the question, here's some advice that may help you make it through this material. Keys to answering proportion or probability questions. First, draw pictures. Only then use Table Z. Use pictures with areas to the left of Z to make puzzle pieces which fit together to give you the picture that you want. This material is the foundation for the next several topics which involve calculations. If you don't comprehend z-scores and probability, you will struggle, especially with the reasoning to come. Students who draw pictures tend to comprehend the material faster. If necessary, print out the picture of the normal curve with the formulas, the IQ scores, and the z-scores. So what proportion of z-scores are below 2.15? Look for z equal to 2.1 plus 0.05 in table Z. Notice you divide the z-score into the tenths part and the hundredths part. Look for the tenths part to find the appropriate row in table Z, and use the hundredths digit to locate the column. Where that row and that column intersect will be the area to the left of the z-score. You should see 0.9842. This gives a visual image of how the probability is found using the StatCrunch probability calculator. The graph was created using software to highlight the area of interest. Notice the mean is 0 and the standard deviation is 1, and the probability find is less than or equal to 2.15. The answer matches what was found in table Z when you round it to 4 digits after the decimal point. What proportion of z-scores are less than 2.15? Remember, in statistics, we want to answer questions in a complete sentence. So the summary can be written as the proportion of all z-scores which are less than 2.15 is 0.9842. Note, z-scores are always rounded to the hundredths digit. That way you can use table Z. Now try another one. What proportion of z-scores are between 0 and 1.26? Look for z equal to 1.2 plus 0.06 in table Z. The proportion of z-scores between 0 and 1.26 is what? How can we use the information below or from table Z to find the solution? How do you get the answer? We would calculate 0.8962 from table Z, or the output below, minus 0.5 equals 0.3962. Recall, half of the area, 1/2 or 0.5, is to the left of the mean, which is 0. So to get rid of that portion, simply subtract that 1/2. In summary, we would state the proportion of z-scores which are between 0 and 1.26 is 0.3962. In general, the steps in finding a probability associated with data which comes from a normal distribution are: identify the mean and standard deviation for the data, identify the value or values of interest, convert the values of interest into z-scores, use the normal curve areas table or table Z, and summarize the results in a complete sentence. Now suppose that the amount of soda in 12-ounce cans of Diet Coke is normally distributed with a mean mu equal to 12.05 ounces and a standard deviation sigma equal to 0.05 ounces. What proportion of all 12-ounce cans of Diet Coke have less than 12 ounces of soda? To find the solution, let's begin by letting X represent the amount of soda in a randomly selected can. First, notice that we have a normally distributed random variable. The population mean, mu, is 12.05 ounces, and the population standard deviation is 0.05 ounce. We want to know how often the amount of soda in cans is less than 12 ounces. In symbols, this is X less than 12 ounces. Next, we convert X is less than 12 ounces into the Z-scale. Z equals X minus mu over sigma, which equals the value minus the mean over the standard deviation. So that equals 12 minus 12.05 divided by 0.05. So that equals negative 0.05 over 0.05, which ultimately is negative 1. So the proportion of cans with less than 12 ounces of soda is the same as the proportion of z-scores which are less than negative 1. We must use the fact about the normal curve to figure out the answer to the question. You should be drawing pictures at this point. Locate the area under the z-curve to the left of negative 1.00. Using table z, we look up z equal to negative 1.00, remember as negative 1.0 and 0.00, and get an area of 0.1587. Hence, the proportion for z less than negative 1 equals 0.1587. In summary, the proportion of cans with less than 12 ounces of soda is 0.1587. The graph on the next page gives a visual representation of the proportion or the area we just found. When we work with the normal distribution, we have seen how to answer the question, what proportion of data lies in a certain section of the graph? Sometimes we want to answer a question involving probability, such as, what is the probability that one randomly selected observation gives a value in some range? The methods are the same for the two questions. Both involve converting to the z-scale and using table z to locate the area of interest. Notice area equals the proportion equals probability. The wording is different depending on whether you ask about a probability or a proportion, but the way to do the math is the same. Let's mention some notation. When you see P with something following in parentheses, this is used to indicate you are finding a probability. So P left parenthesis X greater than symbol 5 right parenthesis is read as the probability that the value of X is greater than 5. This notation would be read as the probability that Z is less than negative 2 in the middle. And the last example is just the probability that the z-score is between negative 2.25 and positive 1.25. Suppose the amount of soda in 12-ounce cans of Diet Coke is normally distributed with mu equal to 12.05 ounces and sigma equal to 0.05 ounces. This is the same as before. B. What is the probability a randomly selected can contains between 11.98 and 12.03 ounces of soda? So we convert the question into the z-scale by changing 11.98 and 12.03 into z-scores. For 11.98, we calculate z to be 11.98 minus 12.05, then divide by 0.05 to get negative 1.40. For 12.03, we calculate z to be 12.03 minus 12.05, then divide by 0.05 to get negative 0.40. Then we note that the probability that negative 1.40 is less than z is less than negative 0.40, or that a randomly selected z-score is between negative 1.40 and negative 0.40, can be written, the probability of z-score is between negative 1.40 and negative 0.40 is equal to the probability that z is less than negative 0.40 all the way to negative infinity minus the probability that z is less than negative 1.40. Using table Z, this gives 0.3446 minus 0.0808, which equals 0.2638. So the probability that a randomly selected can has between 11.98 and 12.03 ounces of soda is 0.2638. These exercises are for you to practice. The brief answers are given on the next slide. Suppose the amount of hours worked per week for full-time students follows a normal distribution with mu equal to 20 hours and sigma equal to 4.5 hours. What is the probability that a randomly selected full-time student works A. more than 26 hours during a week, B. between 15 and 22 hours during 1 week, C. less than 15 hours during 1 week, D. between 25 and 30 hours during 1 week? Work on your own and check your answers. Again, there are very brief answers on the next slide. I'm not going to show that slide just to prevent you from accidentally seeing the answers before getting a chance to work through the practice exercises.